Welcome back, everyone. This is Azam tuning in, and today we will be doing. Today we'll be doing exercise 2C. This one is a short one. I'm gonna try to do it fast because I need to go to sleep and I'm tired. But let's go ahead and get started. Okay, number one, it's asking us to find the domain and ranges of the following functions and state the equations of any asymptotes. Okay, one is going to be y is equal to 3 divided by 4 minus 2x. All right. So first, let's find any limits that it has or asymptotes. Let's find its horizontal, right? Vertical. Let's find its vertical asymptote, and its vertical asymptote is something that y cannot equal. Remember, 1 divided by x does not exist. So we know that there's always going to be a asymptote at there. So that means we can set this bottom equation down here to 0 to find out what our first asymptote is going to be. And with that, we get x equals 2. So we know our equation for our asymptote is going to be x equals 2. And we know that our domain is going to end up being all real numbers such that x does not equal 2. Okay. The y part is a bit trickier. However, what we need to basically do is isolate x by itself to find the horizontal asymptote. So to do that, we're going to multiply each side by 4 minus 2x, and then we'll get 4y minus 2yx is equal to 3. And to get x by itself, we'll do I'm blanking. Oh, yeah, okay. We'll do negative 2y times x is equal to 3 minus 4y, and divide both sides by negative 2y. We get x is equal to 4y minus 3 over 2y. And as we said last time with our x, this equation is true for all real numbers for y such that y does not equal, the denominator does not equal 0. And in this case, that means y cannot equal 0. So coming up here, we know our horizontal asymptote is going to be y equals 0. And that means our domain or our range is going to be all real numbers such that y does not equal 0. Okay, and this is our answer. On to number 2. Let me try to write in the lines here. Y is equal to negative 1 over 3 minus 6x. Okay, same thing as last time. Let's go ahead and just set our domain equal to all real numbers and then find its limitation. Once again, the denominator cannot equal 0. So that means x cannot equal negative 1/2. Or just 1/2. Okay, I'll write it out, I guess. Negative 6x is equal to negative 3. X is equal to hold up, 1/2, which means that this is actually our equation for one of our asymptotes. We'll just write that. Actually, we'll just go ahead and write it up here. But that means x cannot equal 1/2 in our domain. And then to find, as we said, the horizontal asymptote, we're just gonna isolate x. So we'll multiply both sides by 3 minus 6x to get y, or 3y minus 6yx is equal to negative 1. Then negative 6yx is equal to negative 1 minus 3y. Then dividing everything by 6y, we get x is equal to 1 plus 3y over 6y. And then once again, our denominator cannot equal 0, so that means y cannot equal 0. And that also means our asymptote is going to be at y equals 0 once again. So we can come up here, write y equals 0. And for our range, y is equal to all real numbers such that y does not equal, does not equal 0. Okay, on to number 3. We have y is equal to, okay, this one's going to be a bit different than our last one since we now have an x on the top and the bottom. Our range is going to be this, okay, ignore that background sound. Our range is going to end up being this, or our domain is going to end up being the same thing that we did last time. Domain is equal to all real numbers such that x does not equal, when we have to find out the equation here when you plug in x and you get 0 to find what x does not equal. In this case, x does not equal negative, or no, just 1/2. And that means our vertical asymptote is going to be at x is equal to 1/2. By the way, I might be getting my verticals and horizontals wrong. I'm 90% sure I'm not, but if I am, then my apologies. Okay, here's where it starts to get difficult. We want to isolate x by itself. So first, we're just going to multiply both sides by 2 minus 4x to get 2y minus 4xy is equal to x. And then from here, we're going to get our x terms on one side. So we're going to get 2y equal to x plus 4xy. And you'll see the reason why I did this in a second. Reason why is because now we can actually factor. How do I draw this? Okay, it's better if I do it down here. It's not getting better. Wow. Dang. I feel like I'm doing it backwards. Okay, but now we can actually take out an x term from here, so we can put our x on the outside and have 1 plus 4y, because you see that just factors in there. So now we can divide both sides by 1 plus 4y to get 2y divided by 1 plus 4y is equal to x. And now for a horizontal asymptote, we just find out what happens, or what y has to equal for the denominator to be 0, and in this case y has to equal negative 1/4. So we can already just write negative 1/4 here, and that means our range is going to be equal to all real numbers such that y does not equal negative 1/4. Okay, on to number 4. Already halfway done. Let's go. We have y is equal to, I hope like the rest of these exercises are like that, and I'm probably going to regret saying that because I'm going to go to the next ones. You have like 40 questions. Okay, remember domain here, domain is going to be all real numbers such that x does not equal 1 in this case. So when x equals 1, the domain is not, or well, the equation is just not going to exist, which means that our first line of asymptote is going to be x equals 1. And now doing what we did last time, let's multiply both sides by 1 minus x to get y minus xy is equal to 1 plus x. Getting the x terms on one side, we're going to get y minus 1 is equal to x plus xy. So then in that case, we have x factors out, plus y. And then we'll get the equation x is equal to y minus 1, y plus 1, which means that y cannot equal negative 1. So our horizontal asymptote is going to be y equals negative 1. And our range is going to be equal to all real numbers such that y does not equal negative 1. Okay, on to number 5. You know what? It's time to switch colors. Red. I think it's Spider-Man theme going on. Okay. I didn't do the wrong problem, right? Okay, no. Y is equal to 1 minus, that is not a 2. 1 minus 2x divided by 1 plus 2x. Sorry, this is like an ugly red. This is a pretty ugly red. It's too bright. Okay, once again, domain is equal to all real numbers such that x does not equal, in this case when x equals negative 1/2, the denominator is 0, which means that our horizontal asymptote equation is x equals negative 1/2. Okay, and then solving for our y value, multiply both sides by 1 plus 2x. Isolating the x terms, we'll end up getting 2xy plus 2x is equal to 1 minus y. Let's factor an x out of here to get 2y plus 2 is equal to 1 minus y. Which means that x is going to be equal to 1 minus y divided by 2. I'm just going to factor that out. Y plus 1. And once again, when the denominator is equal to 0, that is when we get our asymptotes and whatnot, and that occurs when y equals -1. So our horizontal asymptote is going to be y equals -1. Our range is going to be equal to all real numbers such that y does not equal -1. There's some other ways you can write this. You can. I'm gonna say that and just like get it completely wrong. Pretty sure you can write it like this, which excludes -1. That might be completely wrong, by the way. I do not like check me on this or check me on this. Just don't do this until you search it up. Okay, on to the next one. We're switching out of red because I didn't like it. Ready to go for lighter blue this time. 6. This is the last one, right? Yeah. Awesome. Y is going to be equal to -2x minus 3 divided by 2 minus 3x. Okay, once again, domain is equal to all real numbers such that x does not equal, and setting up an equation here, get -3x plus 2 is equal to 0. Why is the handwriting just getting worse? Plus 2 is equal to 0, -3x is equal to -2. X does not equal 2 over 3. And our equation is going to be x equals 2 over 3. I know that seems counterintuitive, but remember this is the asymptote. Okay, coming back down here, multiplying by 2 minus 3x on both sides, we get this fun little equation. Actually, I should have factored that out to each of these. Remember, this is becoming positive and negative because we have a negative on the outside, which means that isolating each of these terms, we get 2y minus 3 is equal to -2x plus 3xy. 2y minus 3 is equal to x, 2 plus 3y. X is equal to 2y minus 3 divided by -2 plus 3y. Let me just confirm that's all true. Yep, okay. And remember, denominator can't equal 0, which means that y does not equal 2 over 3. So that means our horizontal asymptote is going to be 2 over 3 too. And our range is going to be equal to all real numbers such that y does not equal 2 over 3. Let me rewrite that, 2 over 3. And that is going to be all for today. Hope you enjoyed today's short video, and I'll see you all next time.